This is my Physics 2211 Lab 2. So in Lab 2, I analyzed an object in free fall. Its surface area created a significant amount of drag force against the gravitational force, which was mainly analyzed in Lab 2. The main equations used in Lab 2 were the position and velocity update formulas, as well as Newton's second law, which states that the net force equals ma. The momentum principle is also used and states that the object will change its motion when exposed to a new net force, therefore explaining the change in velocity as drag force increases with time. So this is the force diagram that was used. So here we can see that the force drag acts up against the force of gravity, but the force, the net force is for the most part still downwards, as terminal velocity was not quite reached. My lab consisted of two computational models, the drag force and no drag force, which were analyzed in GlowScript, alongside my experimental values, and the position versus time graph of each one was compared. And it was found at the end of the lab's completion that the drag force played a significant role in the object's position versus time, with the line with drag force and experimental line being nearly identical. Here's my experimental video. The surroundings are the air and the gravity acting upon the object. The air being air resistance, which creates drag, and gravity just being the force downward. And the system is the object dropped. So. The purpose of Lab 2 was to analyze a familiar setting of an object in free fall and find how big a difference drag force made on the positions recorded. So here are my experimental values in Tracker. It was pretty routine. I just plotted the points of the point mass and found the object's position versus time. And here are my initial conditions in GlowScript. So the object mass is 0.005 grams. The initial position was found in GlowScript to be this number. And the intervals were also found in GlowScript to be 0.033, so it increases by 0.033 seconds per frame in the GlowScript. G is the acceleration of gravity, that's 9.8, and J hat is the unit vector. So the velocity update and position update formula are found here to be velocity final equals velocity initial plus AT, and the position update formula is found to be the final position equals the initial position plus velocity final T. So that is found here in my code. Yeah, it's pretty self-explanatory. And the gravitation and drag force equations in GlowScript are also here as well. So the equation to find gravity is Fg equals mg, so mass times acceleration due to gravity. And the equation for drag force is negative b, a proportionality constant, which I found by basically guessing and checking until the final position was equal to the experimental position. And velocity squared equals times negative j hat, which is the unit vector. So here in Excel, I got all three positions found in GlowScript, and Tracker, and plotted them on the curve. And as you can see, I'll show you. The experimental drag force position graphs are very similar due to the drag force graph being more realistic, as it accounts for all the forces of the object dropped in real life, so drag plus gravity. The position graph of the no drag force projects a significantly larger drop in position due to the lack of upwards drag force. So the object moves further down because drag force does not act upon it. And it's solely models, if any, predict a terminal velocity. Now, the drag force is accounted for in the GlowScript. The velocity versus time model for this drag force graph does account for the terminal velocity, because terminal velocity is reached when the object's drag force equals its gravity force, resulting in a constant velocity being reached. And as you can see, constant velocity is being reached with the drag force graph. Now, what does this mean for the net force if terminal velocity is reached? This means that the net force equals 0. Now, what if the object was initially thrown downwards. Would this affect the terminal velocity? And the answer is no, as shown in the two graphs. I made the initial velocity of one graph equal to -2, and both reached the same terminal velocity of around -2.1. Thank you.